Okay, greetings, YouTube. This is Beautiful Mind. Question came in from pre-cal on find the distance between two cities. So let's take a look at it. So from our text, this is comes from section 4.1, question 57. And the question goes like this. So it says the latitude of any location on Earth is the angle formed by the two rays drawn from the center of the Earth and to the location and to the equator. So like if we're at the center of the Earth, we draw a ray from the center to our location, and we draw a second ray from the center to the equator. It forms an angle between, it forms a central angle, basically. So it says the ray through the location is the initial ray. Now it says use 3960 miles as the radius of the Earth. Now we have, suppose city A is due north of city B. Find the distance between city A and city B given these two latitudes. So like, just to kind of get a visual representation of what's going on, let's choose something that pops. We'll do this color. So say, like one city was here at this orange dot, and you have this ray, and then you have the ray that comes from there to the equator. I guess I could draw it like essentially something like that. And this is like overcomplicating it. I just want you to try to get a sense. And then you have a second city, so city B, say it was down here, and it also forms an angle. So then if we want the distance between the two cities, we could find the measure of the two angles, the central angles formed by the two cities, and then subtract the two. That's essentially what's going on. Like if this was A and this was B. Okay. So what we're using is a formula called arc length. Okay, so let's look at it. So now one of my teachers or mentors, or one of the greats that came before me, said that every time we use a formula, write it down. Okay. So the formula here is arc length, so it's going to be S equals R theta. Okay. But in this instance, keep in mind that, let's do it like this. Theta must be in radians for this to work. If it's not in radians, it's not going to work. Okay? So city A has a latitude of 40 degrees, 14 minutes. So A, 40 degrees, 14 minutes. And city B, 32 degrees, 50 minutes north. Right? So basically, we're just going to say city A's latitude minus city B, and we need to eventually get it to radians, and then we can just plug it into our arc length formula. And also, the radius of the Earth is going to be the 3960 miles, right? Okay. Let's start off by finding the difference between these two angles. So we're going to say 40 degrees, 14 minutes minus 32 degrees, 50 minutes. Now, notice, if we tried to say the top minus the bottom, notice that the 14 minutes is too small for the 50 minutes. So we need to borrow 1 degree so that this will work properly. So we'll continue over here. So 1 degree is 60 minutes. So if we borrow 1, and I'll kind of identify it like that, we're going to borrow 1 from there. So the 40 is going to become 39 degrees, and then we're going to add 60 to 40, and that's going to give us 74 minutes. Now we can subtract the 32 degrees, 50 minutes, and that's what, 24 minutes there, and that's 7 degrees. 7 degrees, 24 minutes. So that's the angle measure between the two cities. Now let's see if we can get this to radians. So in class, we saw how to go from, this is degrees, minutes, and seconds. We want to convert this to decimal degrees. So let's look at the 24 minutes. We want to convert it to a decimal. 24 minutes, we're going to put it over 1. So the conversion, I think, 60 minutes is to 1 degree. So we want to convert this to degrees. So since we have minutes on top, we need to put minutes on bottom. So we have 60 minutes is to 1 degree. Now, the units of minutes are going to cancel, and we're going to be left with degrees. So then we say 24 over 60. These are at least both divisible by 6. So you get a 4 over 10. Then you can divide by 2 again. You get 2 over 5. And then as a decimal, So like if we did 5 into 2, you can do all this in your calculator. I'm just doing it by hand. 0.4, right? So this is 0.4 degrees. Okay. So then that means that this 7 degrees, 24 minutes is really 7.4 degrees. So now we went from degrees, minutes, and seconds to decimal degrees. Now we need to go from decimal degrees to radians. Okay, let's do purple for radians. So now we want to convert 7.4 degrees over 1 times, so we're going to say what, times pi over 180. Notice the units of degrees are going to cancel. We're going to be left with the radians. And I think the instructions say do not round it to the final answer, then round to the nearest mile. So I'm going to keep this answer exact. I'm going to leave it as 7.4 pi over 180. I'm gonna just leave it like that. That's fine, because this is going to be exact. So we're going to use this as our. So this is in radians. These would be our radians, our theta, for our formula. And then so now the arc length. So the distance s is going to be r times theta. So let's go ahead and do it. So again, we said s equals r theta. So then this means now the r we said was a 3960. And theta is this 7.4 pi over 180. So that's the exact result. And then now, after we do this calculation, we'll get a final answer. Then it says round to the nearest mile. Okay. So then this is going to be approximately. Now let's break out our trusty, dusty, rusty calculator. I'm going to let that stay open. Yes, this is what I would like. Reload. Come on. Thank you. Cool. All right, looks like it's okay. I'm going to do it one more time. Yeah, this one's still fine. Okay. So now we're going to say the 3960 times, matter of fact, I'm going to go back, like this. Then I'm going to say now the top, we can do 7.4 pi divided by 180. This should be fine. Okay, and we'll get, nearest mile is 511. It's approximately 511 miles. So then let's go back to Pearson, Pearson, my math lab, and let's see if this works. To the nearest mile as needed, 511 miles. Okay, let's see. That's a reasonable result to get for a distance between two cities. 511. Cross our fingers. Fantastic. All right, that was it. Okay. So that was a showcase on finding the distance between two cities, and this is the kind of work I'm looking to see on an exam. Okay. So a lot of times students don't know to do this, and really all we did was the s equals r theta, but it's really a conversion problem, and so we have to convert from decimal degrees. So to kind of sum it up, we have to go from degrees, minutes, and seconds to decimal degrees, and then from decimal degrees to radians, and that's essentially what this question is asking for. Can you do this conversion? And then once you get it in the right form, you saw it was really quick. S equals r theta, just plug it in and we're good to go in every round. All right. So with that, we will end the session here. And for the rest of YouTube, the best kind of nation is a donation. Okay. This is a free service, which is completely fine with me. But I have been informed to at least have an avenue where people could donate if they want. So just be sure to check the description for that. And we will end the session here. And so from one beautiful mind to another, enjoy the rest of your day. Free your mind. Take the red pill or the blue pill. I don't really remember which was which in the movie. I'm thinking it's the red pill because I remember somebody saying red pill players. I think the blue pill, you go back to sleep. We want to wake up. Let's stay #woke. And let's do some #action and take action and stuff. Here's another little Easter egg for any of my students listening. At least for my pre-cal students, I know I'll offer this for you all. The offer still stands for extra credit if you were to make a YouTube video using something from this section from 4 or 5 to the second half of chapter 4, calculating the height of anything. So if you know the distance from the base and you come up at a 90, and then you know the angle of elevation or the angle of declination, if you make a quick little video calculating the height of something, And you can get a little impressive. You can start with something that you know, and then you can possibly calculate the height of a tree or a building, or something that you wouldn't actually be able to do. And it's just something to do. But yeah, if you can do that, I'm still open to giving extra credit for that kind of stuff right now. So that's just a little Easter egg if you hear this. All right. Again, we will end the session here, and from one beautiful mind to another, enjoy the rest of your day. Like my music? All right, take care.